If you cannot make any of those hours, please email me. So take advantage of the fact that, we're all kind of stuck where we are for the moment. So please email me. I will make an appointment with you. I definitely take it seriously that I am a resource for you all. So ask me questions, email me, and I'm willing to set up kind of impromptu Zoom appointments to get you all what you need. At the end of every recitation, there's going to be one of two things is going to happen. You're either going to submit to me some work that you have worked on during this period, or there's going to be a short quiz on Canvas that you'll have to complete. So those quizzes are more or less designed to be, easier if you're here and very difficult if you don't show up and participate. So my encouragement to y'all is to show up ready to go every Tuesday and every lecture day, honestly. But this time is for you to, again, get all the help you need. So please speak up. Any questions before we get into it? All right, before I get started, it is my intention to record all of these meetings. If I forget to do that, if you don't hear this meeting is being recorded announcement, please speak up. I'm not trying to avoid recording it. It just simply means I forgot. So please remind me. With that, I'm going to share my screen. Let's get started. Can you all see what I'm showing?
Yes.
Excellent. Okay, like I said, this time is for you. So just don't feel like you have to raise your hand or anything. I actually might not see you. When I'm sharing the screen, I can only see a couple of you anyway. So just feel free to unmute yourself and interject. This is going to be quite a bit more informal than the lecture. So as we've been talking about in the lecture, we've been talking about function notation. So let's just kind of put a finer point on that and get a little more practice with it. So to review, let's consider just a very simple piece of function notation. Not necessarily going to give you a context, or just going to use the notation as you all have seen it. So you're probably already reading this silently in your head as f of 3. It's exactly how it's read, but just let's get a little deeper, just remind you of what these different components mean. So there's a function that is called f. We don't know what the function does. We don't know how it maps one thing to another. We just know that its name is f for now, and that's all we need to know for now. F of 3 is the value of the dependent variable, and that is based on the independent variable having a value of 3. So you might have also heard terminology like the input value. So when my input value is 3, my output value that is delivered by the function f is f of 3. So again, I'm not giving you a context. I'm not even telling you really what variables are at play here, what their names are. Just that is how this notation, how it's structured, and what all the different pieces of it are. So in general, functions model the relationship between at least two interrelated quantities. So for the time being, and I think for the whole semester, we're just going to talk about functions that relate one quantity to one other quantity. And the context will dictate what those quantities are and how they're related. So I think the big examples we've been doing in lecture is the time, how a flag is being lowered over time. I know that was a big one on Monday. But every context is going to be a little different, which means the variables and the quantities at play are going to be different with each one of those situations. Any questions so far? Let's go ahead and move forward. So our first example here, the number of calories that you burn is a function of the number of minutes that you exercise. So that function, again, I don't need to know what that rule is. I don't need an expression for it. Let's just let that function be called f. So I have 3 different pieces of function notation here: f of 95, f of c equals 140, and f of z minus f of 40. So what I'm looking for from you all is just a English verbal interpretation of those three different pieces of function notation. So what I would like to do now is give you guys a couple of minutes to think about what each one of those means, and then I'll come back in and check in with you and get a few volunteers for those. So just because I'm going to be quiet for the next 2 minutes, that does not mean you have to be. Feel free to make use of the chat. Feel free to unmute yourself and talk with each other about what you're thinking. But I'm going to bow out for a couple of minutes. When I come back, I will check in with you and get some of your answers. All right, let's see what you think. How about f of 95? Who wants to give me an interpretation of that expression?
That's how many calories you will burn if you've been working out for 95 minutes.
Okay, so how many calories you're going to burn if you work out for 95 minutes? How do we feel about that? Okay, pretty good. So the number of calories you burn when exercising for 95 minutes. And just to put a fine point on, or just to kind of take some of the pressure off you all, I don't need you to word this exactly the way I do. I mean, obviously there's a lot of ways to state the same idea. How about f of c equals 140?
That'd be for some number of minutes C working out, you'll burn 140 calories.
Okay, for some number of minutes C, if you work out that long, you'll burn 140 calories. Very good. So you exercise for C minutes, whatever that C amounts to, and you burned 140 calories. And finally, f of z minus f of 40.
I'm just going to take a quick guess. So for doing activity, like with the function z, for z amount of minutes, you subtract that by the calories you burn doing the second activity for 40 minutes. Is that correct?
Sure. So let me rephrase to make sure I have it correct. Yes. So you do one activity for z minutes, you do some activity for 40 minutes, and then, sorry, I'll pick up from there. What do you do when you have those two?
And then you'll subtract the value you get from using the z minutes by the value you get from using the 40 minutes in that function.
Okay. That's pretty good. Does anybody else have a different way to interpret it? Anybody say it a little differently? Okay, so here's another, what I just heard, was that Robert that I heard from just now?
Yes.
All right, so what Robert said was very good, right on the money. here's a kind of a different way to look at it. So we have a change in calories burned from 40 minutes of exercise to Z minutes of exercise. And one thing I want to bring up, just so you know, the penalty for being wrong in this forum during recitation is absolutely nothing. So like I said, this time is for you all to practice and get the hang of this and to really solidify these concepts in your mind. So if you're worried that you might have the wrong answer, well, maybe you do, but that's fine. No one has ever learned this stuff without making a few mistakes. So please be willing to speak up. Any questions on these three before I move on to something else? All right, let's look at another example. So we're looking at a different scenario here. I'm giving you the two variables. Let T be the time in seconds since a race car began moving after a pit stop, and let capital D be the distance in feet traveled by the car since it first started moving. So first question, which of the above quantities is independent and which is the dependent quantity? So which one of these is going to be independent? Is that going to be time T or distance D?
The time?
Time? Can we explain why that is? Why is the time going to be independent?
Because that's the factor that determines what D will be.
That's a very good way to say it. So let's just look at this. We have time and we have distance. One of those quantities is going to govern the other, or as Jack said it, one of those quantities is going to determine the other. It makes less sense to say that the distance is going to determine the time than the time is going to determine the distance. So the longer you drive, hopefully the more distance you cover. We think of time as being the independent quantity and D, distance, being the dependent quantity. Let's look a little deeper into this example. So first, so D and T are variables. We haven't even brought in a function yet, and now we're going to do that. So we're going to use a function called W to represent the distance D at any number of seconds T. So the first thing we want to do is bring that function in here. So to find a distance for any time, that distance is going to be given to us by W of T. So again, we don't know what this rule is, and nor do we need to right now. We have a function called W that for any time T will give you a distance traveled by that car in feet. So I have a few different interpretations here. So the distance driven in 9 seconds, distance traveled from T equals 2 to T equals 5 seconds, and so on. Again, I'm going to give you a couple minutes to think about those, and I'll come back and get a few volunteers for answers. Again, I'm going to bow out, so work on your own if you'd like to, but I would encourage you, if you'd like, to talk with each other and make your thoughts known either in chat or verbally to get some feedback. And I'll be back with you in just a couple of minutes. All right, let's get started. So, part A, the distance driven in the first 9 seconds. How would we use function notation to deliver that?
That would be W of 9, right?
W of 9, good. So I want distance, so I need to take my independent variable of 9 and have that function act on it. All right, next one, the distance traveled from t equals 2 to t equals 5 seconds.
It'd be W of 5 minus W of 2.
Okay, so I heard W of 5 minus W of 2. One thing I want to ask about that is why would it, could it also be W of 2 minus W of 5?
No,
No. Why not?
because then wouldn't it not be negative at that point?
So
Because
yeah,
then it would depend on the situation, right?
yeah, so it would probably be negative if we went that direction. So keep in mind when you're looking at the change in something, to find the real change, you need to subtract the initial from the final, or subtract the final minus the initial. So in this case, we want W of 5 minus W of 2. I want to know what the change is using time equals 2 as the reference and using my time equals 5 as my final. So W of 5 minus W of 2. And I'm sort of harping on this now because if you haven't already seen, one of the easier things to get tripped up on when you're talking about changes in quantities is how to set up that difference. So next one, cars change in distance in its third 4-second interval. How would I represent that? So how is this one similar, or how is it different to the question in part B? So I'm going to the chat. So in the chat, I have the answer W of 16 minus W of 12. How do we feel about that answer?
Wouldn't it be 12 to 8 because the first interval is 0 to 4, the second would be 4 to 8, and then the third would be 8 to 12.
Yeah, perfect. So I believe that our answer from the chat, W of 16 minus W of 12. The good news about that is that we're still hitting on the real key idea there is that we're looking at a change. So we're looking at some sort of a difference. But yeah, I mean, it really should be, in fact, W of 12 minus W of 8. Because the first interval is not going to start with 4, as you might have thought. It's going to start with 0. And finally, the change in distance over any 7-second time interval that begins at time equals x. How do we feel about that one?
Would that be W of X minus W of X minus 7?
So let's W of x minus W of x minus 7. How do we feel about, sorry, how do we feel about this answer?
Could we use the net accumulation function here possibly?
How would you use that, Serena?
A sub x and then of 7
7?
possibly.
So yes, you could, but I would like to do all of this in terms of the function w. So how would we represent this in terms of the function w? So I want to focus on this answer, w of x minus w of x minus 7. True or false, this is going to give me a change in distance. Is that going to give me a change in distance? So let's think about it this way. That w of x, is that going to give me a distance or is that going to give me a time?
That equation is going to give you a change in distance.
That's going to give me a change in distance, right? So w of x is a distance. W of x minus 7 is a distance. So finding that difference between them, that's going to give me a change in distance. True or false, this is going to give me a change of distance over an interval that is 7 seconds long.
Well, no, because you're taking x minus, well, I guess never mind. Never mind.
Did you see it?
Retracted the
Change your
comment.
mind?
Yeah, it did.
So it actually is a 7 second long interval. When does this interval start? At what time?
Time X.
So what I want is for it to start at time x, but I do not believe that what I have written in red is actually going to start at time x.
Well,
Yeah, because it
what's
should
written
be
in
a
red?
+7, right? That's what I
Right.
was wondering.
So how would you modify this?
I would just make it w of x plus 7 just so that the second interval is further down in time.
Okay. So I think I got what you're saying. So here's the answer that I think is a little closer to what we need. So what I was trying to point out is, you know, in many ways, the first answer that was given here, the one I wrote down in red, yes, it's a change in distance. Yes, it's 7 seconds to allow that change to happen. But I have missed the interval that I wanted. So the one in red, I believe that interval ends at time x.
Mm-hmm.
When in reality, I wanted one that began at time x.
Right.
So just kind of another chance to emphasize how important it is to just to be careful with when you're, especially when you're talking about changes. Where does it start? Where does it end? Which one am I subtracting from which? Things like that. That one is intentionally tricky. Any questions about this one before I move on a little further? All right, good job, everyone. So now we're going to go the opposite way. So I am giving you function notation. Take a couple of minutes and tell me verbally what each of those is representing, you know, specific to this context. Do we feel that 2 minutes is too long, not enough time? Pretty appropriate?
Seems okay.
All right, we'll stick with that then for now. While you're all working, if I could ask you a favor, when I'm sharing the screen, if there's somebody who's in the waiting room, I will not know about it unless I'm happen to be looking at the screen when they show up. So if you see someone's in the waiting room, just give me a shout so I can let them in. You're probably more likely to see them than I will be. All right, let's get back to it. So our first one, 2W of A. What do we think that is saying?
That'd be 2 times the distance.
2 times the distance. How do we feel about that? So I think we're close, but I need something a little more. 2 times what
Or
distance?
2 times the distance at A seconds.
Okay, there you go. So I got 2 times the distance at A seconds. Maybe I'm being a little, I'm going to be a little more exact. Can we get a little more specific, a little more clear about what that means? 2 times the distance at A seconds. I think maybe I'm being a little too nitpicky. So twice the distance traveled by the car after A seconds. So after driving for A seconds, we're going to double that distance. All right, next one, W of C minus W of 8.
That would be the change in distance traveled from time C to 8 seconds.
Okay, I got the change in distance traveled from C seconds to 8 seconds. How do we feel about that?
Good.
So again, I think we're close, but I think what's our initial time that we're looking at for this one?
8.
Oh, 8.
Should be 8 seconds. So no worries. Like I said, this is one of the things that, I've been doing this for a very long time, and I still have to kind of think about that and get it straight. So the distance traveled between T equals 8 and T equals C seconds. And next, W of 7.5 minus 9.
So that would be the distance traveled at 7.5 seconds minus 9.
Yep. So I'm not subtracting a time right there. I'm subtracting the actual distance. So 9 feet less than whatever distance I traveled after 7.5 seconds. And finally, W of 3 plus H minus W of 3.
So that's like the last ones are starting at time 3, and then it's going to be 3 plus whatever number H
Okay.
is our endpoint.
Okay, so we're starting at 3 seconds. How long of an interval am I looking at here?
H second.
Yeah, whatever. We don't know what that means, but yeah, H seconds. So the distance traveled in the H seconds after time equals 3 seconds. Any questions on any of these before I move to our last couple examples? All right, let's move on. And again, I'll just give you a couple more minutes and then I'll check in with you. All right, how about this first one? W of t plus 10 minus W of t.
So this is going to be the distance traveled in 10 seconds after the time is equal to t.
So Samuel says the distance traveled in the 10 seconds after time t. How do we feel about that? I feel good about it. So distance traveled in the 10-second interval following t seconds. Forgive the typo, please. And finally, W of x plus 0.5 minus W of x all over 0.5.
Would that be the distance traveled in 0.5 seconds after x seconds divided by 0.5 feet?
Okay, so you're exactly right. So starting at some time equals x, how far did I travel in the half a second after that? And then I'm dividing that whole quantity by 0.5. So let me ask this, why would I divide by 0.5 there?
It would be the equivalent of multiplying the equation by 2.
Okay, so yeah, so the numerator of that expression, W of x plus 0.5 minus W of x, that's just going to be a change in distance over that half a second interval. And if I divide it by 0.5, I'm going to effectively double that distance. That's also true.
Well, isn't it the change in distance over the change in time? So isn't it just like a rate of change?
Absolutely, and that's what I was hoping a few of you would realize. So let's go a little deeper here. So I know this is equal to maybe. Here we go. So this is equal to a change in distance over a change in time. So when you see that one change in one quantity as a ratio of a change to some other quantity, you're definitely seeing a rate of change there. Specifically, when you're talking about a rate of change of distance with respect to time, what do we call that rate?
Would it be velocity?
Not quite. Very, very close, though. Speed. So again, this is not a physics class. I'm not going to get too hung up on what the difference is between those two. But the big idea that I wanted you to key on is that, you know, I'm dividing a change in distance over a change in time. I'm looking for a rate of change. Specifically, I'm looking for an average rate of change. So average speed of the car for the half a second following t equals x seconds, or if you prefer, the average rate of change of the car's distance with respect to time. A lot of different ways to say that, but I think the crucial idea for me there is that I'm looking at indeed a change in a rate of change of our two quantities there. Any questions here for these last two? Right, so I believe we have about 12 minutes left. I believe you have an assignment due tomorrow at 9, which is basically kind of like a crash course in the basics of GC. Has anybody had any problems with that, or does anybody have any questions that we might be able to get to the bottom of in here?
Yeah, I'm assuming I've kind of been all over the place, so I skimmed the syllabus.
Mhm.
Is GC like an absolute required component? Like we're not allowed to use our own calculators?
So yes, it is, because, so I'll give you a couple answers to that. So I'm assuming you have a TI or a Casio graphing calculator.
Yeah.
And those things are great. They're very powerful, very good resources to use for homeworks, tests, or anything else. GC does quite a few things that calculator cannot do. And we're going to be asking you to do things that your TI calculator cannot do. So yes, the short answer is GC is a requirement. So if you haven't already downloaded it, go do that now. I believe the very first announcement that Mark put in Canvas was about instructions on how to download that and how to get it to work. And
Yeah, I got it. I'm kind of lazy with the learning how to type things in it, but it's okay. I'll be fine.
so, and one thing, so you're not alone. You know, GC is it's a powerful piece of software, but with any piece of software that has a lot of capabilities, there's a learning curve to it.
Yes.
And I'm fairly confident that the primary purpose of that first assignment was just to get you kind of get your toes in the water to make sure you could do the basic things. So if you haven't already, this goes to all of you. If you haven't already done so, please download it and start tinkering with it. I'll say this because I know it has come up a couple of times. Do not purchase it. The purchase code or the serial number, whatever terminology they use, Mark has provided that, so you should be able to get a free license of this. But yeah, I just want to reemphasize, yeah, this is going to be required. This is not going to be the first assignment that is exclusively in GC that we're going to be collecting from you.
Gotcha. Thank you.
Thank you. Any other questions about the assignment or anything else, really? Anything else we're doing in the class?
So my computer hasn't arrived yet. I ordered it quite a while ago.
Oh no,
and
okay.
I don't have one. So is there another way I could do the assignment or something?
Yeah, there should be computing commons, but on ASU, but that doesn't mean that you're necessarily going there. I don't know how many of you actually go on Canvas that often. What was your name? I didn't see who had that question.
Oh, my name, Jackson.
Jackson Castro. Okay. Let me look into that, and I will email you to see what we can do.
Yeah, and also just to, like, a piece of like I heard, but the library will also give you a laptop just using your student ID.
Okay.
There's some stipulations, but they'll provide you with one.
Okay.
Okay. Thanks. That's actually really helpful. Thank you.
Okay. Yeah, that's really good. Yeah, if you're willing and able to get to campus, that's a really good resource. Thank you, Robert.
Also, GC is available on your phone. You can purchase the app.
Okay.
I would totally do that, but I don't know if it would count because I think the assignment is meant for you to do it on a computer to learn how to do it on there. So because I will eventually have my own computer, but if
it's available on the phone, I'm sure that all the commands and all that stuff are going to be the same. I just don't know how easy it would be for you to print your work or save it to a PDF. Any other questions before I?
Yeah, I have a question.
Go for it.
So for the
I think you muted yourself.
for the homework, the GC intro homework.
Yep.
It says that we need a GC Windows for Calculus 1 handout. Where can we get that?
So I emailed you those. I think I emailed you all those handouts. So I emailed out a reference sheet for PC and one for Mac. If you don't have that email, I believe if you go to Canvas, let me stop sharing so I can make sure that I tell you exactly where to get these things. But I believe if you go to Canvas, under modules, one of the very first things on there is those reference sheets. Let me go make sure that that's the case. So on Canvas, under modules, yeah, so under modules, the second heading there is GC for Calculus 1 handouts. And there's one for Apple, one for Windows.
Okay, yeah, I found it. Thank you.
Yeah, no problem. And I would encourage you all to either print those or bookmark them. Like I said, GC is very powerful, but it's also little tough to get started on with learning. So those are valuable resources. I use them as well. This is my first time using GC, so I definitely need to read the references as well.
Did you also say that there would be an assignment for this class due on Friday?
Yeah, there's one that I don't know if it's published yet, but it's going to go live, I think, at 3 o'clock, and that'll be due on Friday.
Okay, thanks.
Thank you. And in addition to that, there's a quiz that I am going to give you all access to right now. So if you go on Canvas, and I will, even though it's going to be live very shortly, and even though the class ends at 12:50, I'm going to stay in the room just in case anybody has any issues. There should be a quiz under Recitation Quizzes in Canvas, titled R01. Yeah, click quizzes.
I'm actually having trouble. So is this under the same dashboard, like under the same class as the Calc 2 lecture, or is it separate?
Yes, it is. So yeah, everything is being housed under the where you get all the materials for the lecture. Yeah, there is a quiz titled R01 function notation.
Gotcha.
So click on that. You will need an access code. The access code is baseball. I'm going to put that in the chat as well. So you have 10 minutes to do that quiz from the time that you open it. So it's 12:46. That is all I had for you, and unless you guys want to ask me some questions about homework or concepts from the lecture. But all you owe me right now is to go do that quiz. If you want to stay logged into Zoom while you're doing that, I'll be here. Otherwise, I will see you all in lecture, or I'll see you next week. Thank you, everybody.
Thank you.
And we're free to leave once we finish. Is that correct?
Yes, that's the case.
Okay, just making sure. Thanks. Bye.
Thanks.